Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of parent functions. This is standard A.7C in the great state of Texas, and we are using item number 50 off the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have quadratic functions p and q, and which of these best describes graph q? So p was transformed to create q. One thing they don't say, but we should be able to recognize here, especially with our points, you notice how this p right here has a point of 2, 4, and then negative 2, 4. So this is pretty clear that p of x is going to be our parent function of just equals x squared. So it's the most basic quadratic function you can think of, and that's typically what we'll see in Algebra 1. We'll see the basic function of x squared, and then we're going to transform it. And in this case, two different things happened. Number one, q flipped upside down, and then did you notice that the origin shifted up? Okay, so let's talk about the two different things that need to happen in order to flip it upside down and shift the origin. So or the vertex. So let's talk about that vertex. So how do we shift that vertex? Well, we do it like this. Q, let's make that a q of x equals x squared, and then let's say plus c. It's this plus c, this add-in that we put on after the x squared, that is going to shift our vertex up or down. So it shifts it vertically, either up or down. How we know the difference is c. If c is greater than 0, then it's going to have a vertical shift up. So since the y gets more positive as you go up, c greater than 0 is going to move the whole thing up. And so if c is less than 0, it's negative, then it's going to be a vertical shift down. Regardless of the way this thing is pointing, we need to see what happened to my vertex. My vertex moved up 2. That's why you see a whole bunch of 2's over here. So how do we shift it up? Well, we're going to shift it a positive 2. And so I'm looking at either this one or this one. But honestly, it's not going to be this g right here, because when you have this inside the parentheses, these are horizontal shifts. That's actually a horizontal shift to the left. This is actually a horizontal shift to the right, this negative 2. So I'm thinking it's looking like j. How do we get the flip? Well, the flip is when you do this. You do q of x equals ax squared. You put a coefficient there in front of the x squared. Okay? And that stretches it or widens it, but if a is less than 0, it actually reflects or flips across the x-axis. So it reflects it upside down. If a is less than 0 but greater than negative 1, it's going to reflect and widen. If a is less than negative 1, is going to reflect and narrow. So those two different bands there, they both reflect. And then if a happens to equal negative 1, which it looks like it didn't narrow or widen, it simply reflects. So this a needs to be a negative 1, which we can just translate as negative. So see this negative right here? That negative is looking pretty good. So let's plug that into our graphing calculator to double check. So we'll start with our parent function here, x squared. Then we're going to go ahead and just put in this negative x squared, and then plus 2 is what we thought to shift that up. We'll graph. So the blue is our parent function, and there is our q of x. It flipped upside down and shifted up 2, so that is our answer J.